So, first of all, thank you for coming. My name is Hugh McCamphill, and I'm here today to talk to you about the benefits of capturing test results information over time, and how by combining this with visualization tools, it'll help you achieve insights to support your goals of having robust, reliable, and timely tests. A couple of things before we get started. I work for Liberty IT. Where together with our sister office in Dublin, we develop technical solutions for our parent company, Liberty Mutual. Liberty Mutual is a Fortune 100 company with business and IT operations right around the world. The dots you see on the screen just represent the IT operations. I'm a software engineer in test with Liberty IT. My role currently is mostly helping development teams do better testing. But I've been writing automation on and off since 2004, starting back in the Windrunner days, through QTP, through to using WebDriver since 2011. I've been organizing the Belfast Selenium meetup since 2013, and I'm also the co-organizer of Test Bash Belfast. Test Bash Belfast are a set of Test Bashes are a set of conferences from Ministry of Testing, and I'm delighted to be bringing it to Belfast in May this year. So on to the talk. There can be many things that we need and want from UI automation, but I'm just going to focus on a couple, particularly from a continuous integration perspective, a couple of attributes that we'd be interested in. The first of these is we want our tests to be quick, to have short execution times. Primarily, we want short execution times to have quick feedback loops, to have short feedback loops. UI tests should be no different from any other types of tests. If our tests are too slow, then what happens is developers don't want to wait for the feedback from them before continuing the development. And obviously, there can be a number of factors for the slowness. Maybe, as discussed yesterday, it could be issues with locators, maybe the logic for interacting with a particular element, if you have a particularly funky JavaScript dropdown. Perhaps also could be issues with the application itself, or maybe we're trying to do too much as part of the test itself, doing some navigation or data setup that isn't necessarily important to the test. So we wanted to look for pointers on where these issues might be. We started to think about what we'd be interested in. The first of these, obviously, is which tests are slow. So at a high level. At a lower level, we might also be interested in what steps or methods might be slow. The second of these is that our tests should be deterministic. If tests are deterministic, we mean to say that when we run the same test a number of times, we should find the same result each time, given if everything's equal. So essentially, if our automation is in sync with the application under test, a test failure should clearly indicate and clearly depict an issue in the application. But if the test sometimes passes and sometimes fails, for no clear reason, what people sometimes call flaky, or as Marcus was talking about yesterday, flappy tests, you can't say for sure if that's the case. So essentially the test is non-deterministic. Martin Fowler has a very nice blog on non-determinism from 2011, where he says that if you have non-deterministic tests, what happens is you end up shrugging your shoulders when these tests go red. And once you start ignoring a regression test failure, then that test becomes useless. And you might as well throw it away. It goes further to say that flaky tests are also infectious. So if you have a suite of 1,000 tests, and you have failures amongst those suite of tests, then that suite is often going to fail. Initially, people will look at the failure report, see the failures are due to the non-deterministic test. But if they don't keep up the discipline, then a failure in a healthy test will get ignored too. And as he says, at that point, you've lost the whole game, and you might as well get rid of all the tests. On the other hand, even if you keep up the discipline, what happens is these tests start to become really, really expensive. More and more time is spent investigating these issues rather than learning anything new. And for me as a tester, testing happens when you're discovering new information. And if all you're doing is confirming prior expectations, then you're not really testing. So going back to the premise of the talk, how can we get a better handle on these non-deterministic tests? Obviously, initially, which tests are intermittently passing and failing? But then perhaps also, what are the common failures across tests? So as somebody suggested to me before, that it's not so much that our tests are flaky, but it is that our steps or methods are flaky. So if we can see the patterns across tests, that should help us narrow in on getting these tests to be consistently passing. Alistair Scott had a nice talk from the Google Test Automation Conference in 2015. His central thesis was that flaky tests were being used as a get-out-of-jail-free card. Essentially, people just accepting the failures, rerunning, as if it's always the test problem. I know it's something I've seen. So always a test problem and not an application problem. Because it could be an application problem. The example that he gave was they wanted to release a build. They were in a much more continuous delivery type mode. But they want to have a build released, and about 55 of the 50 groups of tests failed on the first run. They reran the field test, they passed, they released to production. But they didn't ask why they had failed in the first place. And what they found was that users were having sessions being lost or crashed. And when they had a closer look, they found an obscure caching bug. So, in his words, the tests were telling them something, it's just they didn't take the time really to investigate what it was. The flakiness itself was saying something. However, it could also be a testability problem. I used to joke with my manager, this is a few years ago now, but I could bet my life on a particular test passing on a particular application. But this is kind of more before the JavaScript explosion, JavaScript framework explosion. But that's because I knew the hooks into the application to know it was in the right ready state, to know when I should make good use of JavaScript to work around particular WebDriver issues. Unfortunately, that's not the common experience, and I don't think people like to bet their lives on a UI test passing. Alistair Scott says that, and I believe for most of the people here, for testers and test engineers or automation engineers, need to be part of the teams, need to be part of the design teams and the development teams, so that design and testability gets built into the application. And this is for him and for myself as well, this is about much more than locators. It is, particularly with these JavaScript frameworks, about showing spinners for AJAX calls, providing the right hooks for whenever async operations are happening, and not having crazy things like dialogues magically reappearing. So given all this, what could we start thinking about as ways to find out this information? Whenever I first saw Allure being demoed at the 2014 Selenium conference, first of all, I should say that we use Allure. Allure is awesome. But one of the things that I was initially quite interested in was some of the capabilities around the aggregation of reporting. So the defects, common defects across tests, I think is a very nice feature. And then also how long particular tests take to run. However, this, based on the questions I had earlier, this is a partial answer. It's also only going to work for a particular individual run. And for reasons I'm about to explain, I'd be interested in the test information over time. So that leads me on to a tweet from Noah Sussman from a couple of years ago, where he talked about sending unit test result information and coverage to Graphite. In the thread, he goes on to explain that what he wanted to achieve by doing this was to see each individual unit test results over time, each individual unit test performance over time, and Jenkins doesn't have a convenient way to do that. And then secondly, Jenkins itself can be configured to retain data for a long time, but that's not really what it's built for, or any other build tool for that matter. So there are two things that I took from this. The first is the idea of capturing the information over time. If we go back to what I mentioned at the start, the two questions we had about finding generally which tests or steps are slow, we want to see this information over time because an individual test run can have too many variances. If you are running your test in the cloud with a provider like Sauce Labs, already you will know that those tests, individual tests, are slower than if you run locally or in your own Selenium grid. You could also have variances with network issues that on an individual test run don't tell the whole story. And then when it comes to the question of non-determinism, obviously it is by running tests over time we get to see whether they pass or fail. And then the tooling, as we mentioned, Jenkins or any other tools are not really built for graphing this information over time, or indeed storing this information over time. And this really started my own investigations into finding tools that would provide this capability. Graphite was one of the tools mentioned, and this is an example of what some people call DevOps tooling for application monitoring. But there are a lot of tools, and I'll come to the one that I use in a moment. But this is an example of a dashboard with a set of graphs that I eventually ended up with, which I'll walk through now. I'll walk through in a moment. But first of all, how did we get there? So we have a in-house .NET Selenium framework. And the exact specifics of this will obviously depending on your own implementation. The nice thing about this, or the current approach I have, is that it's language agnostic. When we run our tests in .NET, we have our own threading mechanism for running the tests because we use MS Test as our XUnit runner, and it doesn't have a convenient way to actually run the tests in parallel. But we use threads, and whenever we run those, we aggregate the information back together in a JSON file, which then gets translated into an XUnit or a JUnit report. But at this stage, we have this results file. We can then apply some transformations to that to be able to get it into, in this case, Elasticsearch, which is an example of one of these monitoring tools. But we can post this information into Elasticsearch. And Elasticsearch is, as it just says there, a tool for storing structured and unstructured data. But what we're really interested in is the idea of applying it as a time series database, where every time we run the tests, we associate a date timestamp with those set of test results. So to get the type of information we're interested in, as I mentioned, for us, we have this information already just because of the way we're running our tests. But a lot of this information can already be gathered from for example, your JUnit report, your duration, name, class name, etc. Message just represents the error message in the event of failure. Environment is just going to be the test environment. Again, if you're using continuous integration server to run your tests, you probably have a handle on this. And then create it which for us is just the date timestamp of the particular run. And this, just for reference, is how you actually set up the schema for Elasticsearch. And then, whenever you have actually run the tests, you need to build a particular type of JSON structure, which is specific to Elasticsearch. I've started looking to see if we can actually switch to another tool for storing this information, and how it works is completely different, which is interesting, but this is how it works for Elasticsearch. But you can see it's just providing the index, which is the first line, and then essentially the name value pairs for the data that we're interested in at a test level. We currently run all the tests and then have the data gathered and then post it, what they call a bulk upload, rather than having it as a continuous polling mechanism, pushing mechanism into Elasticsearch. I'm not sure what might be better, but I know at least the chances of any performance issues here are minimized whenever we actually do that post operation, rather than it happening as part of your run. So now we've got this Elasticsearch, which is, as I said, operating as a time series database, accepting the information, storing the data over time. We want a way to visualize it. Elasticsearch is part of what's known as the ELK stack. One of the other tools in that stack is Cabana, and Cabana provides the visualization capabilities. There are other tools, again, that you could use instead of Cabana. It just so happens that they do work very well together. And this is an example of the types of visualizations you might see for application monitoring. And then, once you actually have your Cabana instance loaded, there is quite a nice set of different charts and graphs that you can create to create the type of information I showed earlier. So what I'm going to do now is show you how I created one of them. In this case, using the pie chart. What I am going to do here is try to get a visual on the number of tests that are affected by a particular problem. Which tests have failed for the same error for the same reason. Similar to what Allure does, except Allure is obviously for a single run. This will aggregate the information over time. So whenever you initially load this, you get just this big bucket. One big metric, which, depending on the particular visualization you've chosen, could be count, max, or average. It just depends. For this, what we're going to do is split the pie chart into buckets for the top occurring error messages. So now we have the top 10 most occurring error messages. Obviously, the different wages indicate how often this has occurred, but we need to take it a step further. So the next thing we can do is, for each of those wages, split them further into which tests are affected by that particular error message. So when we apply that, and then with the extra icons I've supplied, the inner segments representing the error messages, the outer segments representing, as I said, the tests that are affected by that error. Whenever you're in a tool like this, you can hover over and get to see information. This particular, I think the green segment is, in this case, was actually connectivity with issues with Sauce Labs. The second biggest one is for an element not found, which in this case is just representing the application not loading successfully. So that's the first one. I said, giving us something similar to what Allure was doing, just in a slightly different format. we move on to the next one, this is for the top slowest tests. This goes back, obviously, to we want our tests to be quick. We want to be able to provide quick feedback so as that people will wait for the results. This graph is using the 90th percentile time. So rather than just capturing all the test results, we filter out the variances that may have happened due to network latency, due to the application perhaps just having a bad day, or other connectivity issues. The other thing, obviously, about this, we're not necessarily interested in the absolute time. As I said earlier, if you're running your test locally versus Sauce Labs, I don't know about everybody else, but usually it's about 3 times as slow to run on the cloud. But what I will look at is, okay, there's a couple of tests there at the top that are dramatically slower than the rest. What we found whenever we did look at that really slow test, it was doing much more than I would necessarily expect. I think as Alper mentioned yesterday, I'm also a firm advocate that your UI test should just be a really thin slice of functionality, focusing on the business value, focusing on those journeys, rather than doing lots and lots of validation. So we need to ask ourselves, given this, can we cut some of that out? Or perhaps can we refactor to reduce some of the time? Do we need to do all the things we're doing, like navigation, like data setup? Can we take some of that out? Perhaps use an API to reduce the time. The next graph is around the top failing tests. So I don't tend to think too much in terms of coverage. This is also something else that Albert mentioned yesterday. Particularly when it comes to UI tests, I tend to think more about considering these UI tests as change indicators. So if a test fails, what you're looking for is that it gives you a nice, clean indicator that something has changed, whether that's deliberate or not, or otherwise. But if your signal-to-noise ratio isn't good, and what you're actually dealing with is a lot of noise, then the time you're spending, as I said earlier, investigating these issues, for me, is time wasted. And whenever I first set this up, one of the first things I actually did was go in and delete tests, because I could not see the value. We were just getting this consistent noise that wasn't telling us anything valuable. And if you're not doing this already, please don't be afraid to delete tests. They're not always valuable. This last one took a little bit more effort to create. It took a little bit more effort pulling out the data because it's not available at your test level or as part of your JUnit results file. Because what it's looking at is, if I use the pointer, okay, it doesn't show. The purple line represents how long a particular step took whenever we're performing an action in the application. The green line represents a particular step. So the reason for this first particular spike of a step being done again and again is this particular application just involves clicking next lots of times. And it's just using the name of the action. So that's why that's so long. I can't remember all the others, but what I'm going to give you an example of is by doing this, and by doing this visualization, I was able to see things that I guess I had a hunch things weren't quite right, but by doing the visualization, it really told me that the case. So some examples of what we found where some of that time spent, the purple line, I guess was partly my fault. I had encoded a method for randomly selecting from dropdowns, but the particular algorithm I implemented was okay if you were randomly selecting from 2 or 3 values in a dropdown, but once you've got a 60 or 100 values in a dropdown, then the time just it just extrapolates. Some other issues that we found were XPath lookups in tables, in HTML tables, and then probably the biggest concern was logic being put into page objects to determine what particular state you're in as part of your test. So rather than knowing as part of your test, where am I and what should I be able to do, logic was going into the page object to determine, okay, if this particular element displays, then I should be able to do this. And obviously, the more time you spend performing those validations, where am I and what state am I in, then that all adds up to time being spent. So those are automation issues, if you will. But what this data is actually capturing is, as well as the automation information, is also capturing application information. So whenever I talk about the automation information, the time spent, say, selecting from that dropdown, or sending keys to a text box, that's all in control of your automation. But if you do a search, if you click next and you're waiting for a server response, then that's not something you necessarily have control of. But it will feature in some of these timings. So you just do have to be careful. Is this a reflection on the automation, or are we doing some sort of single user application performance testing? There was an interesting example of that we found. There was some client-side JavaScript logic that was being performed. And if you'd ran it the first few initial times, because of a particular logic, it was fine. But once you start to run some of these tests 100, 500 times, this particular logic was taking longer and longer each time. And that I would have found very hard to see just looking at the test results. The test results that we use, again, this is coming from our own custom reporting, looks like this. So, as I mentioned, getting this information was a little bit harder than just using the information in the JUnit results file. But we already had this, so I thought if we could just take each step has a date timestamp associated, so if we could just take the difference between those, that gives us enough of an approximation for how long the operation is taking. And going back to the example of the text box, what you're interested in is the total time. So if you, in my view, if you do a send keys to a text box, first of all, you do a lookup on the element, then you will check, WebDriver will check, is it still in the same location? Then perhaps you're doing a clear, then you're going to do the send keys, and perhaps you're doing a tab out. So it's a lot of operations actually happening, even just for send keys. So that's why whenever I first looked at about getting some of this timing, I thought perhaps we could look at the information in Sauce Labs. But what I found was the Sauce Labs logging is too detailed. It's every kind of operation. It is find it, is it still there, is it send keys, clear, etc. This way we get something that's maybe a bit fuzzier, but it gives us something more valuable. If you're using Allure, then this type of information will also be easily available. So the visualization is great, but one of the things is people don't necessarily want to go in and look at Cabana every day. So a couple of things that you probably would want to consider. From a UI perspective, you can export this information just from the UI using the CSV file. You can also use Elasticsearch's REST API to get this information. But I would also be looking to set up email alerts. I think one of the things is that, and we haven't quite got there yet, this information needs to get to a steady state position before you start thinking about email alerting. Because a lot of what we have here is, at least these examples, is our initial findings. So how do we get to the point of having tests that are meeting our goal of having robust, reliable, and timely tests, so that in the future, if something changes, then we can confidently email a message to say, okay, something's changed, you need to look at this. And I think also, having listened to Marcus's talk yesterday on location, about storing and grading the information about locators or test information, I think some of those ideas could be applied here, but I would have to give that more thought. And just to re-emphasize, this is storing information over time. So I said we're using Elasticsearch as a time series database. So even within the UI, you can apply different time filters. So you can look at a short period of time recently or over a much longer period of time to be able to really do that trending graphs, those trending graphs. The references that I mentioned earlier, that's from the first one, Martin Fowler's article on non-determinism. And then Alistair Scott wrote up a blog on his talk at GTAC. So both of those are there. So in summary, we wish to have quick and deterministic tests. We could instrument the storing of the data over time, storing it in a database, and then we can visualize that information to help us achieve those insights. This obviously was done with UI automation in mind, but obviously there's nothing that would stop you also adding in unit test information like Noah Sussman talked about, or your API tests as well, if you have those. But thank you very much, and at this stage I'm happy to take any questions.
Thank you for the talk. My question is, how do you post test run results metrics to Elasticsearch? You do it per each test, or you gather all information and then send like a bunch of information?
Yeah, so just the question is, do we do it for each test, or do we gather it all at the end of the suite?
Yeah.
Yeah.
And
so
how do you do it?
So the example we had further back was showing how it was done for all the results, which is this bulk upload. So the bulk message is all the information. So it is, currently we gather all the information and just do it as part of the framework that we have. But I have been looking at having it as a separate task within your build plan, so that whenever all your tests are run, there'd then be a task that would actually do the posting of the results. So yes, it's whenever all the tests are finished.
Okay, thanks.
Hi. My question is, sometimes, very often your end-to-end tests are dependent on each other. And if some prior test fails, it causes failure of the subsequent tests, but it's not the fault of those subsequent tests. Is there any way to, maybe you are using to filter out those results?
So you want to filter out the results that are failing for the same reason? Or the tests that are failing for the same reason, essentially?
For example, in test 1, we open some page. In test 2, we do something on that page. Test 1 fails for some reason, and then we have test 2 which also fails because test 1 failed. But the test 2 itself is okay. So is there
Yeah. So my view is that all tests should be independent. So if you have, like your example of test 2 that depends on test 1, yeah, personally, I just wouldn't do it. It may be then that you perceive the test 2 will then be longer because it has to set up that data.
Yeah.
For me, I think that's just a hit you have to take because there's much more value in isolating your tests so that you don't run into that situation that if test 1 had just a strange blip for some reason, you don't want it to fail all the other tests. So that's why, personally, everything we do, we set it up from scratch, even though we know there could have been data already created that we could have used, but we just go from scratch. And I think that's where using, parallelizing your tests overcomes some of those issues. I don't know if you're doing that already.
Yep. Great, thank you.
Okay.
Thanks for the talk. My question is, okay, so as an output, you got your test, which looks suspicious. But are there any references then to the, let's say, application exceptions? Then so you could check, yeah, is there really something what is going? So what's happening further after that?
Yeah, one of my friends back home, what they do this is in a separate company, they were using graphite just for the unit test, but they were associating the build number with the particular results so that then if they did see something, then they could say, okay, it was this build number, so then they could check back and see what check-ins were associated for that change. Does that answer your question?
Thank for your talk. How often do you perform analysis?
That's actually been one of the challenges of this, in that until we get into a good state, and then maybe get some of the notifications set up, there is a challenge around people looking at this information and really taking it on board. One of the challenges we face is that, like everybody's busy, and we can get a little bit caught up in rerun culture. Like Alistair Scott mentioned that, well, if we run it again, that's good enough. And that's part of the reason why I did this, is to say, okay, I know if you run it again, it'll pass, but that's not good enough. You need to be looking at this information. But in all honesty, that's the challenge of people really taking this information seriously. And I think we also need to go back and bring the whole team into these discussions to say, okay, this information is telling us something, or this information is saying the application isn't as testable as it could be. Does that answer your question? I guess the short answer is not enough.
Okay, thank you. And one more question about your continuous integration. So you have some test suite, and if it fails, just do you fail your job, or you just continue?
So I think the question was, do we just fail the job if the continuous integration job if a test fails?
Yeah, if some test fails.
Yes, we do.
Okay, thank you.
Thanks for your search. I've seen slides with the test steps results, and I've seen slides with the test cases results. And my question is, since you use the ELK stack and data is actually the timestamp tied events, how do you tie them up together if you need such analytics? How do you tie test case to a test step?
We haven't, so I think the question was, how do we have information come from two different sources, the
Right.
test level information and test step information. We haven't done that yet. I think it would make sense to tie them together, but we haven't done that yet.
Thanks.